traveling, working, exploring, participating. The freedom to move about in our communities and our world is vital to us. Being able to share in all life has to offer is essential to our well-being and our quality of life. But sometimes that opportunity is blocked by inaccessibility, and someone's chance to actively participate independently in day-to-day activities is obstructed. Making our communities accessible makes sense for everyone. Accessible facilities are simply more usable, more practical, more inclusive. Simply put, accessibility equals usability. In 1973, the Rehabilitation Act was passed, prohibiting discrimination based on a person's disability in federally funded programs. In 1990, the Americans with Disabilities Act was passed, making accessibility a civil right. Under the ADA, designing and constructing facilities for public use that are not usable by people who have disabilities is discrimination. To ensure that buildings and facilities are accessible to and usable by people with disabilities, the ADA establishes accessibility requirements for places of public accommodation.
So I have to turn around and go back to the nearest crosswalk.
Designers who are familiar with the rationale behind accessibility specifications are better prepared to plan and build projects that all citizens can use, thereby bringing communities together. Economic development, environmental issues, and population trends point to a return to central cities, where people live, work, and play within a central community. This type of development will place a higher premium on pedestrian traffic and efficient in-city transportation. In addition, our population is aging. Baby boomers will begin turning 65 in the year 2011, creating a wave of older workers, drivers, and pedestrians. Our future and the ability of communities and cities to thrive in the future is tied to creating pedestrian-friendly environments that are accessible and usable for everyone. In this program, we'll look at accessibility from several user perspectives. Gary, Boone, Nancy, and Tanya will be our guides as we look at sidewalks, corners, street crossings, and signals. We'll give you an idea of the challenges encountered on a daily basis by people with disabilities and look at ways to design and build facilities that are more accessible for everyone. A good pedestrian route has distinct characteristics that make it both functional and practical. Features include providing enough space for pedestrians to travel, pass, and gather. A well-maintained surface should be firm, stable, slip-resistant, and free of vertical obstructions like lips and bumps. The grade and cross slope should be minimized, making the route flatter and more accessible. The path should be clear, with minimal clutter, obstructions, and protrusions. A good pedestrian route begins with a sidewalk. Sidewalks are walkways that parallel a street or a highway, usually within the public right-of-way. Sidewalk surfaces should be firm, stable, and slip-resistant. Some pavers are not suitable for sidewalks. Split-face stone units, cobblestones, and other irregular surfaces are not easily traversed by pedestrians with mobility impairments. They may catch a dragging foot or trigger a painful spasm in response to repeated jarring in some wheelchair users. These types of pavers are best used as borders and edges on sidewalks that can provide tactile cues for people like Gary. Color contrast and/or texture change in outdoor dining areas helps pedestrians with vision impairments distinguish the walkway from the eating area. Standardization of materials and consistency in use provide the maximum benefit for pedestrians. Other surface features that affect accessibility are gratings and similar features that have openings or gaps that exceed 1/2 inch. These gaps can capture the small front wheels of a wheelchair or the end of a crutch or cane, possibly leading to a trip or a fall. Tanya has to concentrate and carefully place her crutches to avoid an accident. Changes in surface texture may cause a crutch or cane tip to react differently. These metal construction plates are slippery when wet and are an even greater hazard when covered with snow or ice. A wide walkway with a central travel path and limited slope is ideal. Because wheelchairs do not track within the same path when turning, additional length and width are necessary at turns. And because the length of a wheelchair exceeds its width, extra walk space is necessary to turn and operate an entrance door. to approach and activate a pedestrian crossing signal button, or to enter or leave a curb ramp. Narrow sidewalks immediately adjacent to street curbs provide little room for maneuvering. Nancy has to be very careful the wheel of her motorized chair doesn't drop off the edge of this narrow sidewalk. One moment of inattention could be disastrous. Tanya also has problems negotiating this path. Its narrowness makes it hard to achieve a comfortable gait. Tanya's stance may cover up to 42 inches at times in order to be stable. Most people need closer to 48 inches of width for easy passage and to walk side by side. Sidewalks that are at least 60 inches wide allow pedestrians to travel comfortably side by side and are the minimum convenient width for turning or passing. Wider sidewalks are appropriate in many urban areas and where routine pedestrian activity is anticipated. These wide sidewalks invite strolling and shopping and can accommodate larger crowds. Excessive cross slope is a major barrier to travel along sidewalks for pedestrians who use wheelchairs and scooters, those who use crutches, canes, or walkers, pedestrians who have braces or lower limb prosthesis, and those who have gait, balance, and stamina impairments. Cross slopes that exceed 2% significantly impede forward progress on an uphill slope and compromise control and balance in downhill travel and on turns. Because the cross slope is typically directed toward the roadway, pedestrians who lose balance or traction are in danger of sliding towards or into the roadway. Tanya also has problems with this cross slope. It's difficult for her to maintain balance and control with her crutches. It takes significantly more energy to negotiate a cross slope than a horizontal surface, energy that could otherwise be used for forward travel. Tanya is especially wary of excessive cross slope when traveling downhill. She builds up extra speed, which makes control difficult. Any irregularity on the sidewalk which could catch her foot or hold it up can be treacherous. Sometimes, a small change or accommodation makes a big difference. The drive was sloped for cars, but the sidewalk was also sloped to match the driveway apron. A solution would be to provide access to the flat area at the top of the driveway. It will be easier to construct an accessible sidewalk-driveway interface if the sidewalk is set back a few feet behind the curb. The resulting furniture zone provides a good space for street signs, parking meters, and trees without obstructing the sidewalk. Sidewalks in the public right-of-way most commonly follow the grade of the adjacent roadways. If the sidewalk grade exceeds the general grade of the roadway and is over 5%, then they must meet the requirements of a ramp. Where an overpass, underpass, bridge, or similar structure is designed for pedestrian use only, the slope of the access route must be less than 5% or meet ramp requirements. Ramps have a running slope between 5% minimum and 8.3% maximum. Ramps that have a rise greater than 6 inches require handrails on both sides, like this one. If handrails are provided but not required, they still must meet accessibility guidelines. Handrails provide extra stability and support to pedestrians and can help prevent falls. The maximum height of the handrail should be between 34 and 38 inches, and it should be continuous along the length of the ramp and free of sharp edges or abrasive elements. For safety, the handrail may not rotate within its fitting. People with disabilities, older people, and others benefit from a continuous gripping surface that permits users to reach the fingers outward or downward to grasp the handrail. Handrail extensions are required because they allow users to be completely off the ramp and on a level surface before they let go. Edge protection is required to prevent crutches or cane tips from slipping off the ramp, and it must be on both sides. This protection is achieved by using a curb or rail element near the bottom of the handrail, or by extending the ramp surface 12 inches beyond the handrail. The placement of the lower element would prevent passage of a 4-inch sphere, keeping crutches and cane tips safely within the ramp. The passage along or within a sidewalk should be clear of obstructions underfoot, overhead, or in between. Objects that encroach on a path of travel can be a significant hazard for pedestrians who are blind. Elements such as awnings, banners, signs, tree branches, and items that protrude into the sidewalk above a height of 27 inches may not be detectable to people like Gary, who use a long cane to travel independently. This sign is directly in the path of travel. An easy solution would be to raise or lower the sign, add a detectable base, or relocate it out of the pedestrian path. A straightforward, predictable routing along a sidewalk where street furniture, landscaping, and utilities are grouped together in a zone along the curb will facilitate travel for those with vision impairments. In most cities, street-side amenities such as furniture or benches provide accessible resting areas for pedestrians. This is especially important where the sidewalk grade is steep. A level area should be provided for seating and placed away from corners. Given the importance of pedestrian travel and the fact that pedestrian routes are used even when affected by rain, snow, or ice, providing more than the minimum of access features should be encouraged. Sidewalks that shift or settle over time make the maintenance of accessible features important. Sidewalks that may have been smooth in the beginning may not stay that way and then become another obstacle to independent travel. Accessible designs are useless if maintenance is neglected. Erupting tree roots, weather damage, and poor workmanship may cause cracks, splits, and heaving. Maintenance programs that target heavily used pedestrian routes and quickly respond to citizen reports of damage will minimize delays and inconvenience for pedestrians with disabilities. Some new materials offer resistance to cracks, splits, and heaving, which could cut down on maintenance. Curb ramps are one basic unit of accessibility in a pedestrian circulation network. There are three basic types of curb ramps: the perpendicular curb ramp, which may be either normal or directional, the parallel curb ramp, and the combination curb ramp. The perpendicular curb ramp is the most common, with the running slope cutting through the curb at right angles. Parallel curb ramps have a running slope that is in line with the direction of sidewalk travel. The landing or turning space is located at the bottom of a parallel curb ramp, providing access to the street crossing. Combination curb ramps use elements of perpendicular and parallel curb ramps to access sidewalks. Blended transitions, which are large, nearly level areas at corners, may also be used to provide access. Blended transitions occur where the sidewalk corner is depressed or the street crossing is raised, so that the sidewalk and street crossing are at nearly the same level. Curb ramps are comprised of the upslope or downslope, the edges, and the landing. When Boone approaches a perpendicular curb ramp in his manual wheelchair, he ascends the ramp straight on, taking a run at the upslope to take advantage of his forward momentum. The curb ramp needs to be perpendicular to the curb it cuts, so that both sides are the same length. It's important that the base of the curb ramp falls within the crosswalk and entirely out of the path of parallel vehicular traffic. Large level landings or turning spaces at the top of each ramp make it possible to change directions after completing the ascent rather than during it. They also provide a level area that allows pedestrians to bypass curb ramps entirely. With this kind of space, Tanya can keep both crutch tips on the ground, resulting in a safer trip. In some cases, intersecting curb ramps must share a landing. Enough space should be provided so that the edges of the curb ramp do not intrude onto the flat surface. Slopes on turning spaces are not permitted to exceed 2% in any direction. Curb ramps which have a cross slope or a slope which is running perpendicular to the direction of travel of more than 2% may cause a loss of contact with the surface and can make them unusable for people with disabilities. The edges of the curb ramp must be flared if pedestrians will be walking across them so as to not present a tripping hazard. If the adjacent surface is landscaped or pedestrian travel is blocked, a flare is not required and a side curb can be used. The ramp surface should meet general accessibility standards of being firm, stable, and slip-resistant. Gratings, access covers, and other appurtenances should not be located in the curb ramp, landing, or blended transitions. Changes in surface texture can be challenging because each type of surface will respond differently to Tanya's crutch tip. Firm, slip-resistant surfaces that provide good contact will facilitate travel. Knowledgeable design, wise material selection, good construction practices, and regular maintenance can help ensure a smooth transition stays that way. The transition from the street to the curb ramp must be flush, without a lip or difference in level. Lips can cause a wheelchair to stop suddenly, sometimes abruptly enough to dislodge the user. Therefore, lips should not be present in the street either, within the pedestrian crossing area. Care must be taken to ensure that pavement resurfacing doesn't create an obstacle to pedestrian travel. Nancy's motorized chair doesn't have much of a problem, but she is shaken and jostled as she crosses the lip, movement which may cause pain for people with certain types of disabilities. Joints or cracks in the sidewalk at the top of a curb ramp can create barriers to movement and instability in the travel path. Slippery surface conditions like rain, ice, and snow make it even more hazardous. Nancy's motorized chair easily tops this crack when the surface is dry, but when it's wet, it's a different story. Curb ramps and blended transitions are required to have detectable warnings, a tactile surface feature indicating a change from the walkway to the roadway. This feature is particularly important for Gary. Gary can easily detect a difference when he encounters the truncated dome surface of the detectable warning. His cane may reflect the different sound and feel of the surface material. For someone who doesn't use a cane, the truncated domes provide the needed warning because they can be detected underfoot. Detectable warnings should be provided anywhere a pedestrian route intersects a street and the curb has been removed. They should also be placed at the sidewalk edge if the roadway has been raised to the same elevation, as is sometimes done as a traffic calming treatment. Detectable warnings should generally not be placed at driveways, unless the driveway functions as a street, for example, where the driveway movements are signal controlled. Detectable warnings are required to contrast visually with adjoining surfaces, so they can be used for guidance by pedestrians with low vision. Over the last 30 years, the wheelbases of our trucks and buses have gotten longer, necessitating larger curb radii at some corners. This has greatly reduced the sidewalk area available for signs, signal boxes, and pedestrians. Where curb radii are large, pedestrians may not be in the driver's line of vision. In addition, drivers turn at higher speeds, often failing to yield the right-of-way and intimidating pedestrians. Smaller curb radii have traffic calming effects, slowing driver speeds and giving pedestrians the opportunity to begin crossing before the vehicle turns. A smaller radii also keeps the pedestrian in the driver's view and shortens the crossing distance and time. For Gary, intersections with smaller radii provide more audible distinction between perpendicular and parallel traffic flows. Pedestrians who have vision and mobility impairments are increasingly at a disadvantage as they leave the sidewalk to cross the street. Computerization of traffic operations has allowed substantial increases in traffic volume by designing maximum vehicle time and space utilization, usually at the expense of pedestrians. The simple, straightforward street-sidewalk grid with 90-degree intersections controlled by fixed time signaling has been replaced with free lanes for turning traffic, roundabouts, multi-phased crossings, and right turns on red. Pedestrians like Gary, with vision impairments, are at a particular disadvantage when approaching these intersections due to lack of useful information. They use audible and tactile cues to travel independently, using traffic sounds to navigate intersections. Complex continuous flow lanes and intersections make it very difficult to determine traffic movement based on sound. Common visual cues that sighted pedestrians use, signals, crosswalks, and curbs, don't provide useful information for Gary. Drivers are required to yield the right-of-way to persons with white canes or service animals, but that rarely happens.
Walk sign is on. Walk sign is on.
Accessible pedestrian signals with an audible and a tactile component are needed to make signalized intersections accessible to those with vision impairments. As the pedestrian begins the transition from the curb to the street to crossing the street, the condition of the road itself becomes an issue. Gutter lips, grates, and drainage problems can be barriers to crossing the street. The effect of standard surface drainage design on curb ramp usability has not yet been resolved in street engineering practices. In fact, many features designed to manage water flow are problematic to accessibility. Drainage and accessibility must be considered together for proper street design. Where there is excessive cross slope or warping of the roadway, it becomes a major barrier to travel. The cross slope of the roadway becomes the grade that pedestrians have to traverse. Multiple layers of asphalt may have made the crown very steep. If the roadway is wide, islands may be incorporated into the design to provide a refuge from traffic. Unless the island is wide enough to ramp up and down with a landing in between, islands should be cut through level with the street, and the cut should be at least 6 feet in length. Cut-throughs should be at least 5 feet wide in order for 2 pedestrians to pass. Narrower medians should not be regarded as pedestrian refuge. Therefore, signals should be timed to allow for crossing the entire street in one pedestrian crossing cycle. If there is signal activation in the median, space for pedestrian refuge must be provided. Detectable warnings must be installed with a gap in the middle to allow pedestrians with low vision to understand the nature of the crossing and recognize a pedestrian refuge area. A minimum 2-foot gap in between detectable warning surfaces should be provided within the median cut-through. Pedestrian signals at street crossings should provide a clear distinction between walk and don't walk symbols and should have colors identifiable by persons with low vision. Even so, sometimes Gary finds it necessary to use the signals on the sidewalk from which he is departing, because pedestrian signals are not distinguishable with his low vision from across a 4-lane roadway. A solution here could include an accessible pedestrian signal, or APS, with audible or vibrotactile indicators, increasing its usability. Pedestrian push buttons must be located adjacent to an unobstructed level landing to comply with the requirements for clear ground space at operable parts. A minimum landing size of 48 inches by 48 inches is recommended to serve both a side and a forward approach. The push button should be within reach range of this clear ground space and mounted at a nominal height of 42 inches. This height will normally result in the button being within allowable reach range. If there are obstructions near the button, such as a signal foundation, the engineer should verify that the reach range requirements will be met. You can see that it's important that the vibrotactile feature be placed in line with the crosswalk to help users orient properly. Placing each push button near the curb ramp and the crossing it serves helps all users navigate the intersection. Another consideration is crossing times. Crossing times that are based on the old average walking speed of 4 feet per second will not be sufficient for pedestrians like Tanya who use crutches. New regulations require the use of a slower walk speed and a longer crosswalk length when calculating the duration of the pedestrian phase. Solutions to make streets easier to cross include programming signals to increase the amount of time allotted for crossing and decreasing the distance to be crossed by using small curb radii or neck downs and bulb outs. Street signs and informational signs need to have adequate character proportion, height, contrast, and a matte or non-glare finish to be usable by pedestrians with vision impairments. Engineers should refer to the Manual on Uniform Traffic Control Devices, or MUTCD, as well as current accessibility regulations to ensure compliance. If signs protrude more than 4 inches beyond their post, the bottom of the sign must be at least 80 inches above the pedestrian path, since it is not detectable by cane. Accessible pedestrian signals, or APS, communicate information about the walk phase in audible and vibrotactile formats, in addition to the traditional visual format. By emitting an audible locator tone, pedestrians are alerted that the crosswalk is equipped with an APS. A locator tone also helps the user identify the push button that activates the crossing interval. Accessible pedestrian signals can also be equipped with speech technology that announces the street name and the direction of travel. Speech technology is not generally required unless there are 2 accessible pedestrian signals on a corner that cannot be separated by a distance of at least 10 feet. Research has shown that the audible signal is especially useful for those with cognitive impairments and older people who have slower reaction times. Recorded announcements indicating crossing intervals have been shown to enhance pedestrian safety in general, increasing everyone's awareness, but may be hard to hear with loud ambient noise.
Wait to cross First Street at Elizabeth.
The signal controls should be in close proximity to the curb ramp and crosswalk. Pedestrians who are blind should not have to travel more than a few feet to operate the button and then return to the curb to orient themselves for the crossing.
And that's a perfect example.
When a request is made for an accessible pedestrian signal, an engineering study of the intersection should be done. The design engineer may wish to visit with the requesting citizen, as well as an orientation and mobility specialist to better refine the signal system design and operation. Evaluations that result in a high priority or are associated with a specific request should be scheduled to have APS installed. Other features that serve pedestrians, such as bus stops and shelters, must be accessible. Nancy demonstrates a common problem for her in her motorized chair: bus shelters that don't allow adequate space to maneuver into enclosures for pedestrians who use wheelchairs. Using this shelter forces Nancy to travel uncomfortably close to the edge of the sidewalk. Bus boarding areas must be a minimum 5 feet by 8 feet and must be connected to streets, sidewalks, or other pedestrian circulation paths by an accessible route. Accessible on-street parking spaces are best located where the street has the least crown and grade and in close proximity to key destinations. Spaces should be distributed throughout the length of the roadway. Adjacent sidewalk space should be free of obstructions, including curb ramps, to permit deployment of a van side lift. For one-way traffic, it may be necessary to increase the number of access aisles provided or permit backing into the space to locate the access aisle on the side of the vehicle where it will be needed. There may be times when the pedestrian circulation route is affected by sidewalk repairs or construction. These work sites contain a number of conditions that may present potential obstacles and dangers to pedestrians when not cordoned off from public use. However, a variety of measures can be taken to reduce potential safety and access problems at construction sites. Most importantly, a continuous pedestrian route must be maintained at all times. This alternative route must allow pedestrians to bypass the construction without going significantly out of their way. When a temporary route is established, it must be accessible. Multiple information sources, such as signs, audible information, and electronic information sources, should be used to provide advance warning of a construction site. These information sources should utilize simple and easily understood graphics and conform to Americans with Disabilities Act standards for accessible design, TAS, Texas Accessibility Standards, and the Texas Manual of Uniform Traffic Control Devices, TMU-TCD. It's important to make pedestrians aware of the construction site and the change in circulation route before the construction actually begins, so that pedestrians have sufficient time to learn and plan alternate routes to reach their destinations. Indicate the duration of the construction and the type of work being performed. Advance information makes it easier for pedestrians to plan an alternate route. Continuous barriers that can be detected by cane must be constructed to prevent pedestrians from entering the construction site. Flagging tape, ribbon, or signs that identify a construction site without using detectable barriers is unacceptable. One way to maintain pedestrian traffic through a construction area may be to close off one lane of traffic at the construction site, allowing the outside lane to be used as an alternative pedestrian circulation route. It is easier and quicker for vehicles to find an alternate route than pedestrians, especially those with vision or mobility impairments.
Chairs, to your mark, go! Chairs are off and running!
As we've seen today, designing and building accessible pedestrian facilities benefits people and communities. Providing sidewalks, corners, and streets that are usable by all citizens means everyone is included, and that's what keeps our communities vibrant and diverse. Innovative designers can lead the way by considering accessibility early in project development and designing solutions that serve all users. By working together with city planners, we can ensure that the promise of the ADA is fulfilled, while at the same time fostering creativity, utility, and cost efficiency in design and construction.